basically, if we should have 2 points from A, which is with x1, y1 to B, with x2, y2, then we can always be told to find the distance of AB, which by now we all know that is always one of the first things you get to learn in coordinate geometry. So the difference in the x coordinates squared plus the difference in the y coordinates squared. Change this. Yeah, and the same could follow for the midpoint of AB. So you would have to, like I told you have to be familiar with almost all the formulas. So if you are told to find the midpoint of AB, that is you basically finding half of the sum of the s coordinates. So S1 and S2, find half of it, and you also find half of the sum of the y coordinate, right? And that gives you the midpoint. Very simple formula you are all somehow prone to, even before the course starts. So the same for the gradient of AB, that is, in other words, could be called the slope, and sometimes represented by the letter M. So we have the slope, it would be the gradient, and sometimes represented by M. It's always the difference in the y coordinate divided by the difference in the s coordinate in the same direction, right? So by the same direction, if you take the first y coordinate, which is y1, before taking the second y coordinate, which is y2, then you would have to repeat the same process at the denominator, that is x1 before s2, meaning it is possible to have the formula as the y2 first, the y1 first. Just make sure you are repeating the same process at the denominator, that is s2 first before s1 first. So this formula is basically always remembered with the change in y divided by the change in x. So that is it about the slope. And the most common of all the formulas, though yet to be discussed, is the equation of a line. The equation of a line. So the equation of a line, which is always derived from actually the gradient of a line. So somehow, if you know the gradient of a line, more or less, you also know the equation of a line. So it's usually going to be presented as y minus y1 equal to m into brackets. That is, for me, especially, I would always be presenting it as this. But this is basically the gradient of the line rewritten in this format, right? Because if you want to find the equation of a line, you always need two components, the gradient and a point on that line. So if we want to find the gradient of a line, usually we need 2 points on the line. So to find the equation of a line, you can assume you are using the formula to finding gradient of a line, where this time you are using only 1 point and representing the other point with just variables x and y. Yeah. So assuming we are finding the gradient of the same line and our first point is y, we make our second point y1, then remember we follow the same process. So it's supposed to be x and xy. And this I've written basically is what the equation of the line is. So if I should cross multiply, I would have m be multiplied by x, x1, and this is equal to y minus, so y minus y1. And this formula is basically what we have here, right? So that is it about the question of the line. Then another thing about that's the fifth one we would discuss is the angle between two lines, right? So if we have two lines, maybe crossing the x-axis like this, right? And we have an angle, say, theta in between them this way. Then we are able to find the angle between these two lines. Let me even cross them this way. So that's, so let's say this is the line L1, and this is the line L2, right? And we want to find the angle theta between them. Or we want to find the relationship between these two lines and the angle between them. But before that, we can get the angle of the line L2 with respect to the x-axis as say alpha. We get the line L1 with respect to the axis to say beta, right? Now, just quickly, I would go back to the slope and discuss something, or probably let me discuss it here. So as part of the, let me come back to the slope. As part of the formula for finding the slope or gradient of a line, we could also use, let me do it very small here. We could also use that same, we were discussing the line AB, right? So assuming this is the line AB, and it has the angle alpha here. Now, the slope of this line I just drew can be calculated from the angle it makes with the x-axis. So assuming I'm still calculating the slope of this line, then the slope m of this line is also basically tan of alpha. Tan of alpha from actually sine of alpha over cos of alpha. And we can explain this into details, but it wouldn't really be necessary. What matters more is we knowing that the slope of a line could also be tan of the angle it makes with the x-axis, right? Tan of the angle it makes with the x-axis, where the sine alpha is the difference in the y coordinate, and the cos alpha is the difference in the x coordinate, which eventually comes together as tan of alpha. So for us to be able to find the difference, the angle between two lines, which is the theta, we can somehow borrow some ideas of at least knowing the gradient of the two lines here. So if I'm borrowing the idea we just discussed to this place, we could say that the gradient of line L1, which I'm going to call the gradient of the line L1, which I'm going to call M1, is going to be tan of the angle it makes with the x-axis. And that is what beta, right? And the gradient of the line the line L2, which I'm going to call M2, is also tan of the angle it makes with the x-axis. And that is because the angle is alpha, the gradient becomes tan alpha, right? So from here, we can now try to know the relationship these two lines have with what's the angle. Remember, when we go back to plane geometry, or angles, or whatever it is, so some sort of plane figures that deals with angle, or if we should even go back to something small with length during trigonometry, we can somehow tell the relationship between interior and exterior angles, right? So normally we could find the angle here as say 180 minus alpha, right? But if you remember one of the properties too, we have this property that says that the external angle of a triangle being say A is always equal to the sum of the two opposite interior angles, right? So B and C. So basically, A is equal to B plus C. Now, even if you don't know this, still, you can find a way to find the last interior angle left here. The last interior angle left here from the A, then you sum the three interior angles. So after doing that, it will still bring us to the exterior angle being equal to B plus C. So when we come back to our graph, which is the one in black, we know that alpha, or let me use the interior one. So if I'm using the interior, maybe we don't remember the interior one would mean that theta plus beta plus the one in the orange is actually, the angle in the orange is 180 minus alpha. And the sum of the interior angle is what? 180. So from here, we could easily get that alpha is equal to theta plus beta, right? But remember, the angle we are interested in is actually the theta. So why don't I make theta the subject? Theta becomes equal to alpha minus beta. Now, I'm somehow close to finding the angle between the two lines and what it has got to do with the gradients of the two lines, right? So what if I want to find, what if I want to find the tan of both angles? So tan of theta and tan of alpha this way. Then I can probably expand the right-hand side further, borrowing some ideas from trigonometry, right? So if you remember from double angles, this is basically the same as tan alpha minus tan beta all over 1 plus the product of the two tans, right? So tan alpha, tan beta. And just at the beginning of our work, we had explained what tan alpha and tan beta is. We said that the gradient of line M1 can be identified from its angle it makes with the x-axis, and that of L1 was tan beta, and that of L2 was tan alpha. So knowing that M1 is the gradient of L1, I can replace it with so tan alpha is actually M2. So I have M2 minus tan beta, which is M1, divided by 1 plus tan alpha, which is M2 and M1. So this gives me what tan of theta is. And somehow, because we already knew the two lines, it meant that we already knew what the gradients of M1 and M2. So basically, we are able to find the whole of this value. We are able to find the whole of this value anytime we are given two lines and told to find the angle between the two lines. So this is always going to be some kind of a constant, right? Going to be some kind of a constant. So I'm being given two lines. I'm told to find the angle between the two lines. I mean, by the grace of this formula, means you are able to find that angle without even having to draw the two lines, right? Because all you would need is the gradient of the two angles, the gradient of the two lines and the formula. So basically, it's as if we have tan theta is equal to K. And from here, if you remember from trigonometry, we are all able to solve something like this. All we do is to find the tan inverse of both sides, or eventually say theta is equal to the tan inverse of what? The K. And the rest is just a simple value we can compute, right, from our calculator. So that becomes the relevance of this formula. And of course, you can get two different angles between the two lines. This could be the acute angle. We can get another angle if the line is extended, right? So if this line is extended this way and this way, we realize that we can now get another angle from this side, which is going to be just 180 minus the previous angle. I mean, it is a straight line. The sum of an angle on a straight line is 180. So if the first angle we generated from that straight line is theta, then the other should be 180 minus theta. So the same way means we can also generate we can also find the angle between the two lines. That is the other angle between the two lines. If it is not the theta minus, if it's not the theta we are looking for, then the other angle could be what? The 180 minus the theta, right? So that means we can also come here and find tan 180 minus theta to be equal to so it would be just you using the double angle formula again, tan theta minus tan 180 minus tan theta all over 1 plus tan 180 tan theta. And tan 180 is actually 0, right? So the numerator is actually left with tan theta. And because the tan 180 is 0, it means that the denominator, this part goes to 0. So we are basically left with 1 at the denominator, and that eventually gives us minus tan theta. Remember, we just solved for tan theta, so we can easily know what minus tan theta is, right? That would be we negating everything in this blue circle, which I'm coming to make green now. So it is we negating everything here. So it is me taking minus of m2 minus m1 all over 1 plus m2 m1. This becomes the angle between the other angle between the two lines. Yeah. So I think, yeah, I come to the internal divisions of lines and external divisions of lines. I mean, basically we have already discussed the normal midpoint of two lines, but we could also discuss the divisions of two lines. So division of a line, which when it is not necessarily an equal division. So division of line, when it is not an equal division, we could have, assuming we have a line, obviously always we are going to use one of these x1 and y1 thing, s2 and y2 thing, and assuming we are dividing the line AB with the point R, which we are calling small ab and small a and b, right? So let's say the first distance from A to R is m, and the distance from R to B is m. Then we can find the point R, right, by one of these formulas from the internal and external division. So for now, the diagram you have there is basically about the internal division. And this formula is not so different from the midpoint formula. So one good thing you can do is you can choose to not necessarily even remember this formula, or to not necessarily chew this formula, but you can always remember this formula. You wouldn't have to cram it, but you would always remember it. And how to do that is, let me even quote the formula for the midpoint now, right? So remember, for the midpoint formula, we used to have that it is S1 plus S2 all over 2 and Y1 plus Y2 all over 2, right? Now, this time, we are giving the divisions with the only difference between the midpoint formula and the internal division formula is this time, the division is not equal. That is, to make it simple, the division is not 1, 1 or 2, 2 or whatever. So from A to R to B are not equal. So here the assumption is the distance from A to R is not the same as the distance from R to B. Hence why we are not dealing with midpoint formula. And in the midpoint formula, take it as a special case of the internal division where they assume M and N to be 1. And in that case, normally, that would have meant that the first division, the second division is the one I've written. That's the M is the one I've written here. And the N is the one I've written here. And this 2 here was the summation of 1 plus 1. So that means, in other words, I could generate the internal division formula as, so internal division, I could generate it as, now let me repeat the x1 and the s2, s1 plus s2, right? That's our ratio we are using this time. It's not 1:1, but so the ratio we are using, then arrangement of the ratio also really matters, remember. So the ratio we are using is n:m. Now, assume n to be the first value of the ratio and m to be the second value of the ratio. Now, in this way, if you are coming to write the formula for the internal division, you know that you give the second value of the ratio to the first coordinate and the first value of the ratio to the second coordinate for both the x coordinate and the y coordinate. So this will mean that the m will always be going with what? The x1, and the n will always be going with the s2. So basically, all I have to do to be able to remember the formula is, because m is the second value of the ratio, I would be multiplying it by the first coordinate. And I would also be multiplying n by the second coordinate. Remember what we do in the midpoint formula. All we were doing was basically doing what? Adding the two ratio. That was how we had the 2. So the ratio was 1, 1, and we added them to be 2. So this time we don't know the ratio, but we know that they are m and n. So it's just a matter of me adding the 2, m plus n. So this way now tells me that by mimicking the same for the y, I could have my y1 plus my y2, and all I have to do is, because it is y1, I have to multiply it by the second value of the ratio, which is m, and I multiply this by the third value of the ratio, which is n, and I do the sum. Yeah. So if you know this, you wouldn't even have to remember this as formula, because sometimes you could have your ratio to be, say, what if your ratio is, say, maybe m:n? You've realized that now something has changed. The variables have changed, but it doesn't mean you maintain the same formula. So this time, your formula for the internal division changes. So if it is S1 and S2, you have now the second value of the ratio is n this time. So that should multiply the first coordinate, which is the n here. And the first ratio is this time m. It multiplies it this way, then m plus n follows. So you see the differences. Yeah. So once you know this, you won't get confused with the formula, no matter the kind of variables that has been used in the question and all that. And I'm doing this because usually you may not see the same variables, and usually the questions wouldn't be direct that find the internal division. They will come in application form, and you would have to be very maybe sharp to tell how to use the formula to solve your application question. So y1 goes to with the second value of the coordinate, which is, sorry, that should actually be n, right? So n, and y2 goes with m, and I divide both sides by n plus n. Yeah, so that is the formula for the internal division. Now we can do same for the external division, and I like the external division part very much because it's not so different from the internal division. We don't learn anything new when we are to when we understand the external division and we want to, when we understand the internal division and we want to maybe come in for the external division, we don't learn anything new. the only thing you have to remember is one particular property about external division. Always one of the ratio is negative. One of the ratio is negative. So always one of the ratio is negative. And it is negative for a purpose, right? I don't know if I will have to explain it. Maybe it wouldn't be that difficult. So one of the directions of matching the point from from the first point to the point dividing them sometimes changes direction. So the direction is what brings the negative. So always one of the ratio is negative. And fortunately, it is always the least value of the ratio. Always the least value of the ratio is negative, right? Always the least value of the ratio is negative. Always the least value of the ratio is negative. So what do I mean by that? Assuming the ratio is maybe n is to m, because they are variables, we can't tell which of them is least, right? We don't know if m is the least or n is the least, but what we know is one of these is negative. Now, let me attribute this in a diagram form to tell which of them will be negative now after the diagram. Saying that the least value is negative means if we go to the diagram, it would mean that the shortest division, or the first point closer to the division point, is actually going to be the one with the least ratio. So assuming I have A here and I have B here, external division means that the point dividing A and B isn't anywhere on the line AB. So the points R, which is dividing this whole thing, is not anywhere on this line. It is outside this line, right? It is outside this line. So that would mean I can rather choose that my division point R is actually here. So R is actually here. Now, always the measurement of the ratio starts from the first point. Measurement of the ratio always starts from the first point, which is A, matches to the division point, which is R, then continues to the last point, which is what? B. So if I want to know the ratio of this, of A and B, sorry, if I want to know the external division of A and B, which is A and B has been divided by R, even though R is not, the point R is not on the line A and B, hence the name external division, right? So that would mean that I would be looking for the ratio from A to R to B. And obviously, the ratio from A to R, or the distance from A to R, is always going to be shorter than the distance from R to B. So if I should make the distance from A to R, say 2, there is no way the distance from R to B is going to be less than 2. It will be at least 3 and above. So the distance from R to B could be what? 5. Now, that would mean that the ratio AR is going to be 2, and the ratio for the RB, or the value for the RB, is going to be the 5. And now we can see that the smallest distance, which is the 2, is the one that is going to have the negative, if you should write the formula. Why am I explaining this external division? All I'm saying is external division is you using the internal division formula and negating the ratio that has the smallest value. That is it. So you using the internal ratio and negating the value of the ratio that has the smallest value in the formula. So what is the formula for the internal division? The formula for the internal division, but though we are doing external division, remember. So external division formula is what we are discussing. And we somehow know that the ratio, remember the ratio we are using is n is to m. I haven't negated any yet, right? So assuming from what we have done, I'm using still A and R. Let me assume that n is matching the 2 and m is matching the 5. Then in our mind, it means n is the smallest. Assuming n is the 2 and m is the 5, then somehow we can see that m is the smallest. So m is the smallest. So in this case, if I repeat the formula for the internal division, that is, I have my S1 plus my S2. Now, the second formula, the second ratio, right? This one takes the first m, and the first one takes the second divided by n plus m, right? And I'm still repeating the internal division formula, remember. So y1 plus y2. Then the second ratio m takes this one, and the first takes the second ordinate. Then I have n plus m this way, and I close it. So far what we have is, I'm trying to generate the external division formula, but the formula I've written so far is the internal division formula. Now we get to come to ask ourselves, which of the ratio is the smallest? Remember, you'd always know the ratio. So assuming we know the ratio like I did here, then it means that n is associated to 2 and m is associated to 5. So that means n is somehow the least, right? So if n is the least, then it means n is what I have to negate. So n takes a negative this time, like you see there. Then it means that wherever I see n, I just have to negate it. I just did it for the denominator. I mean, there are n on the numerator too, so I also have to negate it. Let me just clean. The little part I have here. So I just clean the plus, right? So by cleaning the plus, I can now go ahead and put the negative for the n there, the negative for the n there, and the negative for the n there. So I have now changed the formula to make sure all n, which is the smallest value of the ratio, have what's negative. And this formula we have there is the external division formula. So the external division formula is just the internal division formula where the least value of the ratio is negated. So you can take it this way intuitively or abstractly. That is how you can take it. But if you want to really understand it, that was the diagram we were trying to explain here, right? So another way you can explain it diagrammatically is the least value from the ratio is always from the point that is more closer to the first, that is the division point that is more closer to the first point, either A or B, because the external division can also happen at the other side of B, right? It wouldn't be just at A where we had the distance there to be 2. It can also come to the other. It means that sometimes M can also be negative. Yeah. And the reason why I'm also explaining this is you would usually not be given the negative sign. Sometimes you'll be given the negative sign that the division is this to this, and there is a negative sign. So you should be able to tell when a division is external or internal, even if the word internal and external are not used. And you should be able to know when what is the actual division or what is the actual ratio when the word external are used among the ratio. Because they can tell you the ratio is, say, 2:3, and add that the ratio is external. So it divides it into 2:3 externally. So by adding the word externally, it should prompt you that, okay, one of these ratio has to be what's negative. Which of them? The least. Which one is the least? 2. So I have to negate 2 and now apply the normal internal division formula. That's all this is about. So yeah, I've discussed the external division already, and I think I will discuss perpendicular bisectors, or the shortest distance from a point to a line. The shortest distance from a point to a line. So yeah, I can just, yeah, that's okay. So shortest distance from a point to a line. They are always the perpendicular distance from that point to the line. So shortest distance from point to line. So that basically means if I have this line and I have this point, for me to get a shortest distance, I will have to find the perpendicular distance from that point to this line. That is always going to be the shortest, because if I should draw the line from this point to this point, or draw it from here to here, obviously none of the orange line is going to be the shortest. Even as we come closer, none of it is going to be the shortest. The only time we may get the shortest is when the line is perpendicular to, when the point is perpendicular to the vertical line, right? So you get to know that the shortest distance is actually the black line, yeah. And you may have this line with the formula. So this is L1. It may have the equation of the line AX plus, the normal equation of a line, plus C equal to 0. And this is a point, which could be any points, maybe S1 and Y1. Now, the formula tells us that the formula for finding the shortest distance, that is, the distance we are talking about, is, say, D. So the black line is D. And to find the distance D, we say it is the equation of the line evaluated at the point P. The equation of the line evaluated at the point P and taking absolute of, right? So the equation of the line we just had was AS plus BY plus C. If I want to evaluate this using the point P, it means wherever I see X, I put the X coordinate there. Wherever I see Y, I put the Y coordinate there. And I still take the absolute of it. So I basically have X is the X coordinate. So I have to put the point X1 there, plus BY, Y is the Y coordinate. So I put the point Y1 there, plus C. So it is basically me evaluating the equation of the line I was giving, and taking the square root of the two coefficients from the equation of the line. Every equation of a line will have an X and Y variable, right? Every equation of a line will have an X and Y variable. So the coefficients of those two variables in the equation of the line, you take the sum of the squares of them. So the two coefficients are A and B. I take the sum of the squares of them. So A squared plus B squared. And this becomes the formula for finding the shortest distance, or the perpendicular distance, from a point to a line. As simple as that. So you may not necessarily get this as a straightforward question, but it may be, it may come in handy when you are solving, very broad questions. The last thing we would also discuss before we solve our questions is also going to be equations of bisectors of angles between two lines. Equations of bisectors of angles between two lines. So equations of bisectors of angles between two lines. Yeah. So in an instance when we have two lines like this, let me call the first one L1. Let me call this one L2. We have two lines. Yeah. There is a property about the equations of the bisectors of these two lines that says that if I have an angle here called beta, and I want to bisect it with, say, this line, right? And let me call that B1. I'm calling this line B1, the first line bisecting B1. And let's say I also have another angle here, like you can see, and I want to bisect that angle. So I'll have to draw a straight line dividing the angle into two equal parts. And let me call that line B2. Now, B1 and B2 are what we are calling the equations of bisectors of the two angles, beta and alpha. So let me call the second angle I drew here alpha. So the B1 and the B2 we see in orange are the equations of bisectors of the two angles. And one interesting thing you can see about those two bisectors is that they are perpendicular to each other. That is all that you need to be able to really understand the relevance. So, like I introduced the perpendicular angle, B1 and B2 are always perpendicular. So usually when you are told that you have two lines and they are bisecting each other by this line, the first assumption or the first property that comes to mind is, okay, those two bisectors are actually what? Perpendicular. And we use this a lot in when we are discussing squares and rhombus, because usually the diagonals of the square bisect each other at 90 degrees. I think we'll be solving the question with respect to that. One of the difficult questions I added to the tutorial set. We'll be solving one of them with respect to that, and we will see the relevance of this. So I wouldn't really solve a question on this, but just get to know that anytime two lines meet and we still have to talk about their bisectors, then those two bisectors are actually perpendicular to each other. That would mean that if, say, we know the gradients of M1, the gradients of B1 to be M1, then we can easily know the gradients of B2 to be what? The negative reciprocal of what? B1. So that would be -1 over M1. I forgot to talk about that, so maybe I can even check that right now about the two properties with respect to the gradients. So two gradient properties. So the first one says that if two lines are parallel, then if two lines are parallel, that is, let's assume the two lines are L1 and L2, then they have same gradients, right? They have same gradients. That is, M1 is equal to M2. And the second one is in an instance where they are perpendicular. So if two lines, L1 and L2, are perpendicular. So the sign I just made is to tell that something is perpendicular, or it is a perpendicular sign. So if two lines are perpendicular, then the product of their gradients, that is M1 times M2, is going to be -1. This is the same as saying one is the negative reciprocal of the other, because this will imply that, say, M1 is equal to -1 over M2, or M2 is equal to -1 over M1. So either we can say their product is -1, or one is the negative reciprocal of the other. So that is it about all what you should know about the first part of coordinate geometry. And we can now go ahead and solve some of the questions. So With the first question I would want to solve, assuming you all have the tutorial set, I would be going to I don't even know the question to first solve first. Yeah, so maybe let me just use the question 1. I mean, it's a very straightforward question. I can use it to explain some of the things we should do. So the question 1 was straightforward. We were actually given 2 points. So given, oh God. So given the point A, 3, 2, and B, -1, 5, we are told to find the distance between A and B. Of course, you can all do that. So I wouldn't really worry much about that question. Then the next was we should find the midpoint of A and B, which we can also all do that, right? So I'm just assuming we can all do that. So A was find the distance. Let me quickly do it just in case. So the distance, remember, you just have to remember the formula. So that was the difference in the x coordinate squared plus the difference in the y coordinate squared. And we all have, so we are using A as S1, Y1, and B as S2, Y2. So we basically have everything. We just have to substitute. So X1 is 3, Y1, S2 is -1. Already we have a minus, so double minus. And Y1 is 2 minus Y2 is 5 to the square. So eventually we have, so 3 minus -1 is actually 4, which is going to be 4 squared plus 3 squared. And that is going to be 16 plus 9, right? And that is square root of 25, and that is 5. And that is 5 units. Now, B said we should find the midpoint of AB. So I can make it in short as the mid of AB. And the midpoint of AB is just finding half of the sum of the two coordinates. So S coordinates and half of the sum of the Y coordinates. And we have everything at our disposal. S1 is 3. S2 is -1. So I can clean the positive and make it minus. Sorry, it was -1 divided by 2. Then Y1 is 2 and Y2 is 5. So this is what we have. Eventually we have 1 here and we have 3.5 here. Right. That was it. Then the next question was find a point that divides, find a point Q. So basically, if this is A and B, we have to find a point Q that divides A and B in the ratio 2:3, right? So that means here is 2 and here is 3. And you see the question was silent. The point Q that divides AB in the ratio 2:5. And the question was silent. But because the question is silent and the ratio are both positive, it means we are dealing with what? The internal division. But assuming the question was silent and the ratio came with one of them being negative, and it means that question is actually an external division question, right? So it can come in 2 ways, where they will give you both ratio positive and say externally. And that would mean that you would have to make one negative yourself, or they'll give you the ratio with one already negative. And that would mean that it is already an external division, just that they didn't have to say it because they are showing it in the ratio. Yeah. So the first question is find the point Q that divides. So assuming Q is the point we are maybe calling small ab, then our formula is going to be, so first of all, I will have to recognize the nature of the formula, the nature of the ratio I've been given. So the ratio was 2:5. I'll have to know which of them I want to make my N and M. So I just choose anything at all. So I just say something like N:M is equal to 2:5. Someone can make his M is 2:5. However you make it doesn't matter. What matters is how you arrange it after you have quoted the nature of the arrangement of your ratio in the formula, right? So now M is my first ratio and N is my first ratio and M is my second ratio. So that tells me that if I'm putting the formula S1, S2, S1 goes with the second ratio and S2 goes with the first ratio before I do the sum of them. It's easy as that. So if I have my Y1 and my Y2, now Y1 goes with the second ratio M and Y2 goes with the first ratio N, and I sum them. And I have everything already. So all I'm doing is what? Substitution. M is 5. S is, remember we had S here, S1 and S2 here, right? So that is 3:2, right? That is 3:2. So I have S1 to be 3 and N to be 2, S2 to be -1 divided by 2 plus 5. And M is 5, Y1 is 2 plus N is 2, Y2 is 5 divided by 2 plus 5. So the rest is just evaluation. So we have 15 minus 2 over 7 and then 10 over 7. Eventually we have 13 over 7 and 20 over 7 as our internal division point, right? So our internal division point. And the D was the external division. So the external division. And all I need, according to the question, the ratio we have been given for the external division. So assuming I'm calling it N:M, according to the question, the ratio we were given is 3:1. So the question said 3:1 externally, but because I know it is external division and I have to negate one of them, and that one has to be the smallest, I will have to negate negative. I'll have to negate the 1. So the actual division is 3:-1. Immediately I introduce the negative, I am basically repeating everything in the internal division formula, right? So all I have, so another thing you can do is sometimes when you negate the 1, you can repeat the same process for the M. Yeah, so that you will basically be repeating everything in the internal division formula. So that is wherever we see M in the internal division formula, we negate it. So the formula for that, assuming I'm calling, so they call that R. So R is the division we are looking for, and the formula is going to be, that is me, I'm basically repeating the formula in the internal division, but I'm negating M because M is the one associated to the smallest number, which is the -1. So from the formula Q, I have up there. So from this formula, I am just negating M throughout. I am just negating M throughout. So let me use black pen. So I'll have -M x1, right, plus N x2 all over N minus M, then minus M y1 plus ny2 all over n minus m. Yeah, I just copied everything from the first formula by just negating every m I see. And now we have everything at our disposal. We just evaluate them. So we have minus 1, x1 is 3, and n is 3, then s2 is minus 1 all over n, which is 3 minus 1. Then we have minus 1, y1 is 2, plus 3, y2 is 5, all over 3 minus 1. So the rest is evaluation. So I have minus 3 all over 2, and I have minus 2 plus 15, right? All over 2. Eventually, I have minus 6 on the numerator, so divided by 2, I have minus 3, and I have positive 13 on the numerator for the second one. You just divide by 2 this way. And that is it for the external division. These questions are just straightforward, because once you know the formula, you don't have any problem. Now, the next question we have to find is the slope of AB. That's a very straightforward question too. The formula is the change in the y-axis, always y first, divided by the change in the x-axis. So however you take it on the y-axis, if you want to bring y1 first, all what matters is do the same for the denominator, bring s1 first, so as you are finding the change. So we took y1 minus y2 and s1 minus s2. But remember the points we are using. We are using the point A, 3, 2, and B, minus 1, 5, right? So I'm just doing substitution. So y1 is 2, y2 is 5, all over s1 is 3 minus s2 is minus 1. So double minus, right? And we have eventually minus 3 divided by 4 as the gradient. Remember, the gradient can be called m. So that is it for the gradients. Now the F question says, find the equation of the line AB. Find the equation of the line AB. So I have F and equation of line AB. All I need to remember is the formula. Remember, the formula is generated from the gradient. So even if you don't remember this, y minus y1 equal to m into bracket s minus s1. Just remember that, oh, I always get the equation of the line from the gradient, so I can find something out. But of course, this should be one of the formulas you can easily remember always. And to find the equation of the line, we just need a gradient and a point, right? To find the equation of the line, we need a gradient and a point. And because we have 2 points on that equation of the line we're given, remember we're giving AB, both A and B were given, right? Like we have in the pink ink. So all we have to do is take one of those points, and we already have the gradient, minus 3 over 4. So we just also combine it with that gradient, and we are good to go. That is, our gradient for this same line we are discussing, we just found it as 3 over 4. And we probably would want to use any of the points A, B. So I'm choosing, say, 3, 2, which is the point A. Let me rather call it the point A. So now it's substitution. So y minus y1. So the y1 is 2 from the point I chose, and it's equal to minus 3 over 4, which is the gradient, and s minus s1, and s1 is 3. So the rest is me arranging it nicely as my equation of the line. And that would be 4y minus 8 equal to minus 3x minus 3 this way. Then I go ahead and expand the bracket. That would be minus 3x plus 9. So the equation of the line is 4y plus 3x is equal to maybe 8 plus 9, which is finally 4y plus 3x is equal to 17. Now, let me use this to also talk of the fact that when we have an equation of a line, we are able to tell the gradients of that line. I mean, the formula can even do that for us, right? So if the formula, I'm done solving this anyway, but given the formula, y minus y1 equal to m into bracket s minus s1. If I should make y the subject, I have m into bracket s minus s1 plus y1. And I'm able to tell that this guy here is the gradient. That means from what I just underlined and I'm about to circle in orange, I can choose to make y the subject and quickly tell what the gradient of that equation of the line is. So assuming I have the 4y plus the 3s equal to 17, then the gradient of this line is just going to be easy to know by me making y the subject like I'm doing. So I make s cross the equal sign, and finally I divide through by 4. So I will have y equal to minus 3x over 4 plus 17 over 4 actually. So this guy in black becomes our gradient. And that was exactly what we had when we were solving the gradient. So you have to also notice this. Sometimes it comes in handy when you're solving some questions about it. All right. The next question we'll ask is find the equation of the perpendicular bisector. Find the equation of the perpendicular bisector. So G, equation of perpendicular bisector, right? Now, equation of perpendicular bisector is just you finding the equation of the line that bisects A and B. So where is A and B? A and B is a line. A is 3, 2. B is that guy minus 1, 5. So B is minus 1, 5. What do they mean by find the equation of the perpendicular bisector? So we want to find an equation of a line. What the fuck? We want to find an equation of the line that divides AB into 2 equal parts and at the same time is perpendicular to AB. So we have been given 2 information, and those 2 information are enough to find the equation of a line. Remember, if you want to find an equation of a line, we need a point on that line and the gradient of that line. We just discussed the fact that if 2 lines are perpendicular, then their gradient is the negative reciprocal of the other. So this guy I'm calling L is the line I'm trying to find. But that line is perpendicular to AB. So first, I can find the gradient of that line, right? The gradient of L. And the gradient of L is going to be negative 1 over the gradient of AB, right? And the gradient of AB we had found to be minus 3 over 4. So basically, this becomes 4 over 3. Wow, so that becomes more closer to what we are looking for. The last thing we need is to know the points here, which fortunately is also going to be the midpoint, because we are being told that the line L is a perpendicular bisector, meaning the line bisects AB into 2 equal parts. And by bisecting AB into 2 equal parts, it means that wherever it cuts the line AB is the same as the midpoint of what AB. So all I would do is to find the midpoint of AB, and that would be the line, the point that lies on the line L we are trying to find. So the midpoint of AB, we know already, right? We had solved it already in one of the previous questions. So let me quickly get it. So the midpoint was here, and we had it as 3.5. So I go back quickly to get it. We have 3.5. So I have everything I need to find the equation of this line L we are being told to find. So all I do is to now quote the formula. So the equation, so that's in therefore the equation of L, we know it as what? Y minus Y1 is equal to M into bracket S minus S1. And I have all the ingredients. So this implies Y minus, our Y1 from the midpoint is 3.5. Our M, that is the gradient, is 4/3. And our X1 is 1 this way. So from here, all I do is I multiply through by 3. I'll have 3y minus, so the 3.5 is actually 7/2. So that is going to be 21/2, right? And we have 4 into bracket S minus 1. We can do another multiplication with the denominator too. And that is going to be 6y minus 21 equal to 8s minus 1. So we basically expand the bracket this time, and that will be 8s minus 8. So I just arrange it nicely now. 6y minus 8s is equal to 21 minus 8, and that is 6y minus 8s is equal to, how would that be? 13, right? Okay. Yeah, so that ends it for the equation of the perpendicular bisector. And the final question is, find the perpendicular distance from S to 6. Find the perpendicular bisector, the perpendicular distance from S to 6 to AB. So the H question was, find perpendicular distance from S. S is a point, which is 2, 6, to AB. We also learned how to find the perpendicular distance from a point to a line. So this is basically we having AB and being told to find the distance from, say, a point here called S to AB. And they called it a perpendicular distance, meaning that line from the point should be perpendicular to AB. So the point S has been given to us, and we have the point AB already as 3 minus 2 and the minus 1, 5. Yeah, so minus 1, 5. So we are trying to find this distance here. This distance here. And we fortunately also learned how to find that distance from one of the formulas that says D is equal to that is the equation of the line evaluated at the point S. So AS1 BY1 plus C. So that is you evaluating the equation of the line with the point you have been given, right? And dividing it by the sums of squares of the coefficients of those equations of the line. Oh, I have to keep doing this. So we have A squared plus B squared as the formula. So looking at this, you realize that all we need is the equation of the line AB. It was one of the questions we solved. So I'll just go for that. And we use it together with the point S, which is this time representing the S1 and Y1. Remember, the S from the question is what we have as S1 and Y1. This is what has been given to us in the question as 2, 6. And the AS plus BY plus the C is the equation of the line itself. And we actually solved that as one of the questions. So by going back like this, I can see the equation of the line here. That is what we have here, so 4y plus 3x equal to 17, right? 4y plus 3x equal to 17. So the equation of the line was actually 4y plus 3x equal to 17. That was how I wrote it today. But because of the formula, it means I will have to make sure they are all at one side of the equation. So I'm making the 17 cross the equal sign. So we will have 4y plus 3x minus 17. Yeah. So now we have all we need to find the equation, the distance from S to AB. So I have the absolute of 4. So let me start it how it was in the formula. So that would mean that I would write 3s first, or 4y before the 17. So I am basically substituting the A, B, and C before I come and substitute the S so that you get to know what is happening. So I will have 4s1, sorry. I will have 3s1 plus 4y1 minus 17 all over the square root of a squared plus b squared. And finally, I am coming to substitute the s. Wherever I see s1, I put 2 there. That is it here. Wherever I see y1, I put 6 there. So I have absolute of 3, 2 plus 4, 6 minus 17 all over the square root of, so 3 squared plus 4 squared, right? And this is going to be the absolute of, so 3 times 2 is 6, or 6, 24 minus 17, and all this divided by square root of, so 9 plus 16, and that is going to be, so 24 minus 17 is 7, right? So I basically have 6 plus 7 divided by square root of 25. And that is going to be 13 over square root of 25 is 5. So that becomes the distance from the point S to the line AB. We call it the perpendicular distance or the shortest distance. Yeah. And that ends it for that question we just solved. That's the question 1. I'm going to solve a very now. This was just to give us the overview of how we can use all the formulas we just learned. Now, the rest is for you to be able to apply it in solving, very applicable questions that will need a lot of thinking and all that, right? So I'm coming to solve one of those questions. Oh, I didn't write that question. I didn't write that question. Yeah, but I will maybe write it. So I will be typing that question. I should have written that question, but let me not add it. I'll give it as problem of the day. Then we solve it another time. So let me take one question from the tutorial set. Any question you guys want us to solve? Let me just, if I'll get a very nice question. Okay, so let me just solve this question. So the question says that the question 5 on the tutorial set, right? Question 5 on the tutorial set. So it says the equations of two sides of a parallelogram are y minus x equal to 2 and 2x plus y equal to 4. And it says find the equations of the other two sides. Find the equation of the other two sides if they intersect. So if they intersect at 0 minus 4. Yeah. If they intersect at 0 minus 4. So the equation, and so questions like this, like I was saying before, what I always like to do is to represent this whole understanding of the question on my Cartesian plane. So me trying to draw them to scale and all that, though I know it's a parallelogram, I can just draw two lines. I mean, I can solve this in two ways where I would ignore, that is for this particular question. It wouldn't necessarily matter that I draw it to scale because I can, reason with what I'm doing. It's a parallelogram. And they said the two sides have this equations. So by me knowing the properties of parallelogram, a parallelogram looks like this, right? So basically these two lines are parallel, and these two lines are also parallel. And we know the properties of parallel lines. I expect that this one and this one will have the same gradient, and this one and this one will also have the same gradient. So by looking at the two equations I was given, I can tell that they are not parallel to each other, right? So I can just draw the parallelogram and make sure that I'm calling two sides of the equation of the line that are not parallel to each other. So find the equation of the other two sides if they intersect at 0, 1. So I can do that and just call where they intersect as something different. Yeah. So I can draw to scale or not for this particular question, but I always like to draw to scale at least. It helps in a lot of questions we solve where you can't just be doing the reasoning I was just doing, for example. So let's go back to our diagram. So assuming I have my Cartesian plane like this, right? I'm to plot the first equation of the line, y minus x equal to 2. And how do I do that? Sorry, let me draw the lines again. Good, I draw them this way so that wherever it passes, I'll know what's happening there. So to plot the line y minus x equal to 2, I just need the intercept of this line to plot it. So for example, for the first one, if x equal to 0, y is 2, I can assume here to be 2, y equal to 2. This is, of course, the y-axis, and this is, of course, the x-axis. So if y equal to 0, x is negative 2, I can assume here to be negative 2. That means it is a line I'm drawing to pass through this 2 point like this, right? Then I also come to the second equation of the line. If x is 0, y is 4. That is somewhere here. And if y is 0, x is 2. And that is somewhere here. So that is me drawing a straight line to pass through it. Fortunately, I wasn't that straight, the line, but it's still okay, right? So that is the two lines for us. And we know that these two lines come together to form a parallelogram, like the question said. But there are other two sides of this parallelogram we haven't drawn yet to complete the parallelogram. And they say that these two other sides, they intersect at what? The point 0 minus 4. So I just have to plot 0 minus 4. 0 minus 4 is somewhere here, right? This is minus 4. So 0 minus 4 is 6. Meaning I have to complete the parallelogram to make sure it is passing through the point 0 minus 4. So because it's a parallelogram, I know that the first one has to be, if this is line L1 and this is line L2, I know the two lines I should draw to pass through this point should be such that one will be parallel to L1 and another one will be parallel to L2. So I can even draw the one parallel to L2 like this. right? And let me use a different color to differentiate it. So this is one of the lines we are finding, and that is parallel to L2. So I'll call that L3. And the other line should also be parallel to L1. So let me also draw it like this. That is L4. So we are basically finding L1 and L4. Sorry, L3 and L4. And because we know it's a parallelogram, we know that the gradient of L2 is the same as the gradient of L3. And we also know that the gradient of L1 is the same as the gradient of L4. And we have the equations of the line already, so we can easily tell what their gradient is, right? So now I have y, so the gradient of L1. So the line L1 was, that was the first line I drew, right? Okay, that was L2. So L2 was y minus x equal to 2. If I want to know the gradient of L2, I just make y the subject. That will be s plus 2. So basically, the gradient of L2 is equal to 1. And for L1, we have the equation of the line to be 2x plus y equal to 4. And I want to make y the subject. So as I make y the subject, I have minus 2x plus 4. And that means the gradient of L2 is equal to minus 2. Now, for the gradient of L2, it would imply that the gradient of, remember, L2 is parallel to L. So it would imply that the gradient of L3 is equal to 1. And the gradient of L2 will imply that no, what is happening? So this is actually L2. So L2 is here 1. And the gradient of, so this is supposed to be L1 actually. So this is L1. Yeah, so the gradient of L1 is also parallel to the line L1 is parallel to the line L4. So the gradient of L1, which is minus 2, is the same as the gradient of L4, which is also minus 2. So all I have to do now is to combine them together with a point on L3 and L4 to find their equations of the line. That was what the question was to find. The question said, find the equations of the other two sides if they intersect at 0, 4. Remember, at this point is what is 0 minus 4. Yeah, so you will see that L3 and L4 are both passing through that point. So I start with equation of L3. We have the formula to be y minus y1 equal to m into bracket s minus s1. And I have everything already. I just substitute. So the point I'm using is, remember, 0 minus 4. That is where both L3 and L4 are passing through. So I have y minus 4 again, because y1 is actually minus 4. And it's equal to the gradient we had for L3 was 1. I just have 1 there. We don't necessarily write it. But for teaching purpose, I'll just write it to know that I introduced the gradient. And S1 is also 0 according to the question. So finally, we have y plus 4 is equal to x, right? And you can leave it this way, or you can arrange everything as y is equal to s minus 4. So that is the equation of one of the parallel lines we have to find, which is L3. I do the same for equation of L4. And that is going to be y minus, it's basically the same formula. The only thing that changes is the gradient and the point. But in fact, the point is even the same because they are all passing through that same point. So I'm just doing substitution and changing the gradient. Sorry, I made a mistake here. So there is no 1 here. So that is y minus y1. So I eventually have y minus y1 is minus 4. And m this time is, that is the gradient of L4 is minus 2. I have s minus 0. Eventually I have y plus 4 is equal to minus 2x, right? So finally I have y is equal to minus 2x minus 4 as the equation of the other line. So these questions are usually not difficult geometry, because once you remember all the formula, you can remember all the properties. You wouldn't have any problem at all with geometry. I still have some 20 minutes left. We can still solve some other difficult questions. So yeah, let me take this question. It will take us back to Math 102. That's okay. It's not that difficult. The part that will take us to Math 102, Math 101, I feel like we can try it. So another question that says, find all the values of R. Find all the values of R such that the slope of the line through the point R4 and 1, 3 minus 2R is less than 5. So we are trying to find the value of R such that the slope of 2 points, that's R4 and 1, 3 minus 2R is less than 5. So first of all, we know that the slope of any 2 points, or the slope of a line, is always the change in the y coordinate of those points on the line and the change in the s coordinate. And that is actually y1 minus y2, or the other way, s1 minus s2, or the other way. And looking at the 2 points we were given, that means we have, so y1 is actually, I'm taking the first one as my y1 s1 and the second point as my, so this is s1 y1 s2 and y2. So that means I will have 4 minus 3 minus 2r, right, divided by r minus 1. And the question says we should find the values of r such that this slope is less than 5. That is, such that this slope is less than 5. So meaning what I just wrote there, we should find the value of r such that it is less than 5. And you see, it now becomes an inequality question. It now becomes an inequality question to solve. It becomes an inequality question to solve. So all I have to do now is to solve that inequality. Let me quickly rewrite it down here so that you see it well. So we have 4 minus, I'm expanding with the bracket this time. So 4 minus 3 plus 2r all over r minus 1 is less than 5 is what we are trying to solve. Let me simplify the numerator. You have 1 plus 2r all over r minus 1 is less than 5. So it is as if solve this inequality. That is probably what the question becomes now. Solve this inequality. And you know what happens to anytime you are solving an inequality question with a rational expression. When we have a rational function in an inequality question and there is a variable at the denominator, we are forced to make the denominator what? Positive before we can eliminate that denominator, because being in an instance where the denominator is negative and we don't know, it could change the sign, and because we wouldn't know that, it would give us a wrong answer eventually. So it would be appropriate if we first of all square the denominator and use it to multiply through this inequality. So we are basically, we multiply through by r minus r1 squared, right? So that would be r minus r1 squared times 1 plus 2r all over r minus 1 less than 5r minus 1 squared. So one of the r minus 1 cancels from the left hand side, right? So we are left with just r minus 1 and r plus 2r.
Sure.
Yes?
Please, why did you square the r minus 1?
Yeah, so I was explaining that in inequality expressions, anytime you have a rational expression like we have here, which is 1 plus 2r divided by r minus 1, the assumption is if we are dividing through by something and that thing is negative, it changes the inequality sign. Do you remember that property?
Yes, sir.
Yeah. So because we are now supposed to multiply through by the denominator, which we have in the form of r1. Now, depending on what r is, will determine whether the whole of r minus 1 will be negative or positive, right?
Yes.
Right? Yeah. So
Yeah.
because we don't know r yet, r could be negative 1. In an instance when r is negative 1, the whole r minus 1 is what? Negative 2. That means if we were multiplying through by negative 2, then it means the less than sign should change to greater than sign. But this is where we just started solving the question. We don't know yet what r minus 1 is actually going to be. So of course, there are instances it will be negative for some of the answers we are looking for, and there are instances it will be positive for some of the instances we are looking for. So in which instance can we have this expression strictly positive for all values of r? That is when, for example, we have squared it. So for example, if r is minus 1, we would have minus 1 minus 1 giving us minus 2, but minus 2 squared is still positive, right? So I was basically squaring it so that as we use it to multiply through, we still maintain the inequality sign less than. And it's something we always do anytime we are solving an inequality expression with the denominator in the form of an expression. I mean, it wouldn't have been the case if we were solving the question like 1 plus 2r over 5. Maybe, let me change the value, maybe 1 plus 2r over 4 less than 5. If this was the question we're solving, and we want to maybe eliminate the denominator by multiplying through, we wouldn't have squared the 4. Why? Because obviously we can see 4 to be a positive number, right? So that is the reason. This is the reason why. So let me just.
Thank you, sir. Thank you, sir.
Okay, so we continue. Now I do the cancellation, and what we have now is r minus 1 squared. So all I have to do is bring everything to the left-hand side and we play around it. So r minus 1, we don't have to expand anything in this kind of questions. Remember, I used to always say this last semester. So we have everything this way. For example, we can see some like terms, r minus 1 at both terms. So I find r minus 1 as I just factorize it, and I'm left with 1 plus 2r in the first term minus 5r minus 1 in the second term. Is still less than 0 anyway. So all I have to do now is to take my time and solve what is in the big bracket, right? So I have 1 plus 2r minus 5r plus 5. You take your time because there are lots of negatives playing around it. So you take your time and expand them well. So I have r minus 1, then I have 6. I have two constants, 1 and 5. I bring them together, it's 6. Then I have 2r minus 3r. That is going to be minus 2r minus 5r, which gives minus 3r. And everything here is less than 0. Remember what we do here always. So this is an inequality expression. But inequality expression would mean that we would have a lot of answers from this. So we probably would want to know the boundaries to these answers. what restricts these answers. And we can only know those boundaries if, first of all, we convert this whole inequality into an equation. So we let this whole thing be an equation. Remember this equation, this is what will help us get our answer. If you remember from Math 101. So since it's now an equation, we can easily find the values. So r minus 1 equal to 0 and 6 minus 3r equal to 0. So r equal to 1, then 6 is equal to 3r. Finally, we divide both sides by 3, right? So we have r to be equal to 2. Yeah. So we have r equal to 1 and r equal to 2 as our values of r. And these are the boundaries to the values of r we are looking for. So usually you'd realize I would represent this whole thing on a number line like this. So all the values of r we are looking for, they may either be in this region or here or here. Now, how do we get to know that? We get to know that by trying to maybe test the values between this region in our final inequality we had before converting it into an equation. The inequality I've called star, right? So the inequality I just called star is this one. Is what will help us find our true answers for R. So I will just need some values in between these two boundaries. That is, this is a number line, obviously starting from minus infinity to positive infinity. So I obviously can choose any number from minus infinity to 1. I can choose any number from 1 to 2 and any number from 2 to 1 to test the inequality at equation star. So from negative infinity to 1, I can choose a number like negative. I think 0 is even better, right? So negative infinity to 1, I can choose a number like 0 there. From 1 to 2, which is the middle interval, I can choose maybe 1.5 there. And from 2 to infinity, I can choose 3 there. So these 3 values, I'm supposed to use them to test the inequality at star to see what the result is. Now, if you remember some of the shortcuts we used to use for this, we said that because the inequality we were solving actually had a quadratic expression, right? This was a quadratic expression. And we finally had the 2 roots or the 2 solutions from the quadratic to be R1 and R2. That is, it's a quadratic expression and the maximum root it can have is 2. Because we're able to get all the maximum roots, we are able to follow a pattern on which of these intervals will give us the values of R we are looking for. That is, in the instance where the first interval actually is going to be one of the values of R we are looking for, it would imply that the next interval wouldn't be the values of R we are looking for, and the next one will be. That is just because we were able to expose all the solutions of the type of equation we were dealing with. We were dealing with a quadratic equation, and the quadratic equation should have a maximum of 2 solutions or 2 roots, and all those 2 roots were exposed. Hence, I can follow this pattern. So the same way, if the first part of the interval doesn't satisfy the inequality, the assumption is the second part will satisfy and the third part wouldn't satisfy. Some of these things are just things you get to use yourself anytime you really already understand what you're doing. But if you don't understand, you can do the testing for all the 3 values and finally you get your answer because they will still expose the answer to you. So we are now testing values on the equation star, right? So that is, I'm going to substitute 0 in the equation I've underlined or the equation I'm about to circle. So wherever I see R, I put 0 there because I'm using the first number here, right? Remember, I'm using this number. So wherever I see R, I put 0 there. So if r is equal to 0, then I will have 0 minus 1 according to the formula there, and 6 minus 3 is 0. And what is this value? My analysis says if this value I'm coming to evaluate is less than 0, then it means it is exactly what the inequality at star says. Because the inequality at star says that if it is less than 0, then it means that inequality is satisfied. If it is greater than 0, then it doesn't satisfy it, right? So I have minus 1 from the first bracket, and I have 6 from the second bracket. Eventually, this is minus 6. And of course, minus 6 is less than 0. So that tells me that this part of the inequality satisfies, this part of the interval satisfies the inequality, meaning all the values of r from negative infinity to 1 are actually going to be the values of r we are looking for. Now, from the assumption or from the trick we used, it should tell me that the middle part wouldn't satisfy, and this part will satisfy, right? So for me to be sure, I can go ahead and do the same thing by saying if r is equal to 1.5, I also substitute in the same thing here. That is that would be 1.5 minus 1, then 6 minus 3, 1.5, and whatever you get as a constant, the assumption is it is not going to be less than 0. Yeah, that is all what it means. Now, if r is equal to 3, which is the last one, the assumption is if we evaluate it also like we did for the other one, so 6 minus 3, 3, whatever we get here, maybe as Q, is going to be less than 0. So you can just take your time and even do that, and you realize it's really satisfying. So eventually, because the analysis shows that the ones I've marked with the blue pen, the intervals I've marked with the blue pen are the values of r that satisfy the inequality. So it just implies that values of r we are looking for. Remember, the question says that, so find all values of r such that the slope blah 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 is less than 5, and we just did that. So therefore, this implies the values of r are, so the first interval from the -1 to negative infinity to -1, right? And that is it. Sorry, negative infinity to 1. So they are negative infinity to 1 and 2 to positive infinity, right? 2 to positive infinity. So this has, we mean all the, and remember the bracket I'm using. See, I'm not using the square bracket. So it means that the 1 and the 2 are excluded. That is, I am not using minus infinity and 1 with a square bracket like this. And I'm not using this in infinity with the square bracket on the 2, because the question was with a less than. There was no equal sign, right? For all the inequality, there was no equal sign. So it means we use the smooth brackets to say that the 1 and the 2 are excluded from the values we are referring to, right? So I think we would end our conversation here, and